From the tiniest particles to the vast cosmic web, space has shaped everything we know about our universe. Today we'll explore 100 discoveries that transformed our understanding of the cosmos. Facts, mysteries, and revelations that will change the way you see the stars. Chapter 1. The first time humans looked at the night sky with a telescope, everything changed. Stars weren't just tiny lights. They were suns, far away and countless. Suddenly, Earth felt small, fragile, almost insignificant. People realized the universe was vast, mysterious, and waiting to be explored. One tiny instrument opened our minds to infinite possibilities. Space was no longer just above us. It was a story we were part of. Chapter 2. Galileo discovered Jupiter's moons in 1610. Seeing them orbit another planet proved not everything revolved around Earth. It shattered old beliefs and sparked curiosity. Suddenly, the cosmos was dynamic, not static. People began asking, if moons orbit Jupiter, what else is out there? His discovery whispered that the universe follows rules, and humans can uncover them. One glance changed centuries of thinking forever. Chapter 3. The first observation of Saturn's rings stunned the world. Through a simple telescope, a thin halo appeared around a distant planet. What looked like a planet became something more complex, beautiful, and fragile. It revealed that even giant planets have secrets hidden from naked eyes. Rings, orbits, collisions, and dust danced in patterns, showing the elegance of cosmic mechanics. Saturn's halo was proof. Space is full of surprises. Chapter 4. Newton realized gravity isn't just a force on Earth. It governs the cosmos. Apples fall, moons orbit, planets spin, all connected by invisible threads. Understanding gravity turned scattered stars into a predictable system. It gave humans a key to unlock motion across billions of kilometers. Newton's insight was simple yet revolutionary. The universe follows laws we can understand. Suddenly, space felt less like magic and more like a puzzle. Chapter 5. The discovery of Uranus in 1781 expanded the known solar system. A faint, distant dot became a planet, reminding us the sky isn't fully mapped. Uranus challenged astronomers to keep looking, to question what else is hiding. It taught patience. Exploration reveals slowly but changes everything. Our cosmic neighborhood was bigger than anyone expected, and with every new planet, humans learned humility before the vast unknown. Chapter 6. Dark matter, invisible yet powerful, reshaped our view of galaxies. Stars move too fast to be held by visible matter alone. Something unseen dominates the cosmos. This invisible force isn't just a theory, it's real, shaping clusters of galaxies across billions of light years. Dark matter whispers a secret. We only see a fraction of reality. Space is stranger than imagination, and its mysteries are just beginning. Chapter 7. The cosmic microwave background is a faint echo of the Big Bang. Scientists mapped it, revealing the universe's infancy. Tiny temperature variations hint at how galaxies formed. Looking at this relic is like peering back 13.8 billion years. It tells us we are part of a story that began long before humans existed. The universe has memory, and every star we see carries that ancient history. Chapter 8. Pluto's demotion to a dwarf planet shook the world. It wasn't just a technicality. It challenged definitions, classifications, and human ego. Pluto became a symbol of discovery and controversy. Its icy surface, heart-shaped region, and strange orbit told us that small worlds can be extraordinary. Space isn't neat or simple. Sometimes it refuses labels. Even tiny planets have lessons about humility and curiosity. Chapter 9: Exoplanets. Planets beyond our solar system changed how we think about life. Thousands have been found, some Earth-sized, some bizarrely large. Some orbit 2 suns, others dance dangerously close to their stars. The sheer variety proves that planets are common. Life might not be unique, and our solar system is just one chapter in a cosmic anthology. Discovery reminds us, space is endlessly creative. Chapter 10: The Hubble Space Telescope revealed galaxies billions of light-years away. Images show spirals, collisions, and clusters in breathtaking detail. Hubble didn't just take pictures, it told stories of formation, destruction, and cosmic evolution. Each photo is a window to the past, a message traveling through time. Space feels alive, dynamic, and endlessly vast. Humans learned that looking far also teaches us who we are. Chapter 11: Neutron stars are the densest objects we know after black holes. A teaspoon of their matter would weigh 1 billion tons. These stars are remnants of supernova explosions, tiny but incredibly powerful. They spin rapidly, sending pulses of radiation like cosmic lighthouses. Observing them taught us that the universe can compress matter in ways impossible on Earth. Neutron stars are extreme, strange, and fascinating proof of cosmic laws. Chapter 12: Black holes were once theoretical curiosities. Now their shadows have been captured, confirming their existence. These invisible giants bend light, warp time, and swallow everything nearby. Black holes are both terrifying and mesmerizing. They teach that space is stranger than fiction, where gravity reigns supreme. Observing them reminds humans that even light cannot escape certain truths. Space is harsh, mysterious, and full of lessons we are only beginning to understand. Chapter 13: The first detection of gravitational waves shook physics. Tiny ripples in spacetime, caused by colliding black holes, proved Einstein right. These waves carry information across billions of light-years, letting us hear the universe. Detecting them opened a new way to explore space. Instead of just looking, we can now sense its vibrations. Gravitational waves show the cosmos communicates in ways humans are only starting to decode. Chapter 14: Comets are cosmic time capsules. Made of ice, dust, and frozen gases, they preserve the early solar system. When they approach the sun, they release tails that light up the sky. Studying comets teaches us how planets formed and even how life's building blocks arrived on Earth. These icy wanderers remind us that small objects carry huge stories. Comets are travelers, storytellers, and cosmic messengers all at once. Chapter 15: The discovery of exoplanet atmospheres revealed alien weather and chemistry. Some have scorching winds, others rain metal, and a few may even hold water. Observing these atmospheres helps scientists understand planet formation and the potential for life elsewhere. We are beginning to read the climates of worlds beyond our own. Space isn't just stars and planets. It's dynamic, alive, and surprisingly diverse, with surprises waiting in every sky. Chapter 16: The Voyager probes are humanity's ambassadors to interstellar space. Launched in the 1970s, they carry messages, records, and images. They've crossed the solar system, sending data back about planets and cosmic rays. Voyager reminds us of curiosity and persistence. We can reach far beyond immediate sight. They carry a piece of Earth into eternity, proof that human exploration leaves a lasting footprint, even in the vast emptiness of space. Chapter 17. The discovery of cosmic inflation explained the universe's rapid expansion after the Big Bang. Within fractions of a second, space stretched faster than light. This theory solved mysteries of uniformity and structure. It reveals that the universe's early moments were dramatic and extreme. Inflation shows that cosmic history is stranger and faster than everyday intuition allows. The universe has rhythm, drama, and astonishing speed hidden in its first seconds. Chapter 18. Pulsars, spinning neutron stars, are precise cosmic clocks. Their pulses arrive with astonishing regularity, allowing astronomers to test theories of gravity. Some even detect planets orbiting them. Pulsars are tiny, dense, and relentless, showing that extreme conditions create natural laboratories in space. Observing them teaches patience, precision, and the universe's subtle elegance. These lighthouses of the cosmos are both mesmerizing and profoundly useful. Chapter 19. The discovery of dark energy shocked astronomers. The universe isn't just expanding, it's accelerating. A mysterious force pushes galaxies apart, dominating over gravity. Dark energy remains unknown, but its effects are measurable across billions of light years. This discovery forces humans to confront that most of the universe is invisible and unexplained. Space isn't just vast, it's expanding faster than we can fully comprehend. Hiding secrets in plain sight. Chapter 20. The Kuiper Belt revealed a frozen frontier beyond Neptune. Small, icy objects orbit in a distant ring, remnants of the solar system's formation. Studying them uncovers clues about planetary migration and the outer reaches of our neighborhood. The Kuiper Belt reminds us that exploration often uncovers hidden worlds. Even beyond familiar planets, the solar system continues to surprise, showing that space is layered, complex, and far larger than imagination alone can grasp. Chapter 21. The discovery of the Oort cloud revealed a vast, unseen reservoir of icy bodies surrounding the solar system. It's a source of long-period comets, silently orbiting far beyond Neptune. This distant halo reshapes how we see the boundary of our solar system. Invisible, cold, and mysterious, the Oort cloud reminds us that space extends far beyond what we can directly observe, holding secrets billions of kilometers away. Chapter 22. Gamma-ray bursts are the universe's most powerful explosions. In seconds, they release more energy than the sun in its entire lifetime. These bursts originate from collapsing stars or merging neutron stars. Observing them teaches how extreme cosmic events unfold and how matter behaves under unimaginable pressure. Gamma-ray bursts are violent, brief, and spectacular, showing that space isn't peaceful. It's a theater of unimaginable power. Chapter 23. The discovery of supernova remnants revealed the recycling of matter in the universe. When stars explode, they scatter elements that form new stars, planets, and life. Observing remnants like the Crab Nebula shows that destruction fuels creation. Space is a cycle, not a static place. The atoms in our bodies were once part of ancient stars. Supernovae prove that cosmic endings are just beginnings in disguise. Chapter 24. The mapping of the Milky Way's spiral arms revealed our galaxy's structure. Sun, planets, stars, all are part of a vast, rotating disk. Understanding this map helps astronomers predict star formation, motion, and cosmic evolution. Our neighborhood isn't random. It has order and rhythm. Mapping the Milky Way made us realize that our solar system is a tiny detail in a massive, swirling cosmic masterpiece. Chapter 25. The discovery of cosmic voids unveiled enormous empty regions between galaxies. These voids are vast dark spaces with few stars, shaping the large-scale structure of the universe. Their existence challenged ideas of uniformity and showed that the cosmos has architecture on unimaginable scales. Voids reveal that absence can be as meaningful as presence. The universe isn't just matter. It's defined by empty spaces, too. Chapter 26. The first photograph of Earth from space changed perspective forever. Floating in the blackness, our planet appeared fragile, alive, and unique. Humanity saw borders, oceans, and atmosphere as a single delicate system. This image inspired environmental awareness and curiosity about space. Seeing Earth from afar showed that observation can alter perception, proving that perspective is as powerful as discovery itself. Chapter 27. The discovery of fast radio bursts introduced a new cosmic mystery. These milliseconds-long signals come from distant galaxies, often unexplained. Scientists debate origins, magnetars, neutron star collisions, or unknown sources. Each burst is a puzzle traveling billions of light years. Fast radio bursts remind us that the universe constantly sends messages, challenging our understanding and keeping curiosity alive in every cosmic signal. Chapter 28. The detection of water on the moon reshaped lunar exploration. Traces of ice exist in shadowed craters, hinting at resources for future missions. Water is essential for life, fuel, and sustaining human presence beyond Earth. This discovery turned the moon from barren rock to a strategic waypoint. Even familiar neighbors hold hidden potential, showing that space surprises can be close to home. Chapter 29. The discovery of rings around minor planets like Chariklo and Haumea was unexpected. Rings weren't exclusive to giants like Saturn. These tiny worlds revealed that even small bodies can have complex features. Observing them taught that the universe is more intricate than assumed. Rings aren't just decoration. They're evidence of collisions, gravity, and cosmic dynamics. Small objects, big stories. Chapter 30. The first direct image of a black hole's event horizon revealed the invisible. The glowing ring around darkness confirmed predictions of Einstein's relativity. Seeing the unseeable transformed theoretical physics into visual reality. Space can be witnessed, measured, and even photographed in extremes. This image reminded humanity that even the darkest mysteries can become known with patience, ingenuity, and vision. Chapter 31. The discovery of the first extrasolar planets around pulsars shocked astronomers. Tiny worlds survived the death of massive stars, orbiting neutron stars with extreme radiation. These planets proved that planetary systems can exist in unexpected, harsh environments. It changed assumptions about where planets and potentially life can form. Space is resilient, creative, and full of surprises, showing that even in death, stars leave opportunities for new worlds. Chapter 33. The discovery of the Andromeda Milky Way collision trajectory stunned scientists. Our galaxy isn't isolated. It's on course to merge with Andromeda in billions of years. Stars will rearrange, new ones will form, and solar systems may shift. This cosmic dance reminds humans that the universe is dynamic. Even our seemingly stable home is part of a grand, slow-motion performance across time and space. Chapter 34. Observing gravitational lensing revealed invisible mass bending light. Massive objects, like galaxy clusters, warp space, magnifying distant galaxies. This effect allows astronomers to map dark matter and see objects otherwise hidden. Lensing proves that light isn't always straight, and space can act as a natural telescope. The universe has ways of revealing itself if we know how to look carefully. Chapter 35. The discovery of the interstellar object Oumuamua challenged everything. A strange, elongated body passed through the solar system, unlike any comet or asteroid. Its origin from another star system proved that space is interconnected. Tiny visitors from afar remind us that the cosmos is vast, mobile, and unpredictable. Even fleeting objects can rewrite assumptions about our neighborhood in the universe. Chapter 36. The study of solar flares revealed the sun's explosive power. Magnetic fields twist and snap, sending energy across the solar system. These flares can impact Earth, satellites, and astronauts. Understanding them is critical for protection and prediction. The sun is not just a steady light. It's a dynamic, sometimes violent star. Observing its tantrums teaches that space is energetic, alive, and not always calm. Chapter 37. The discovery of Jupiter's Great Red Spot showed a storm lasting centuries. Winds circulate faster than a hurricane on Earth, creating a persistent, enormous vortex. It demonstrates that planetary atmospheres are dynamic and can produce extreme phenomena. Even gas giants have personality, motion, and drama. Observing the red spot is like watching the universe breathe, immense, relentless, and mesmerizing in scale. Chapter 38. The detection of neutrinos from the sun confirmed nuclear fusion at its core. These nearly massless particles pass through everything, carrying messages about solar processes. Observing them proved that the sun shines because of atomic reactions, not myth or speculation. Neutrinos travel unseen, revealing hidden truths. Space communicates subtly, and science gives humans the ability to listen. Even invisible particles tell profound stories. Chapter 39. The discovery of hot Jupiters shocked planet hunters. Gas giants orbiting extremely close to stars defied expectations. These worlds are blistering, massive, and orbiting in days instead of years. Their existence revealed that planetary migration is common, not rare. Space doesn't always follow neat rules. Observing hot Jupiters reminds us that the universe invents endlessly, often defying assumptions and stretching imagination. Chapter 40. The mapping of the cosmic web revealed the universe's large-scale structure. Galaxies form filaments, clusters, and voids, creating a vast interconnected network. This web shows that matter isn't randomly distributed. It has patterns and connections across billions of light years. Space is organized even in apparent chaos. Observing it reveals that the universe is both beautiful and structured, an intricate design beyond human intuition. Chapter 41. The discovery of the first multi-planet system beyond our own revealed that planetary arrangements are common. Some stars host tightly packed worlds, some with eccentric orbits. This reshaped thinking. Solar systems are diverse, dynamic, and unpredictable. Observing these systems shows that our sun's configuration is just one of countless possibilities. Space constantly reminds us that patterns exist, but creativity reigns, even among the stars. Chapter 42. The detection of helium in the sun confirmed predictions about stellar composition. Helium, the second most abundant element, is produced in stars through nuclear fusion. Understanding this unlocked the secrets of stellar life cycles and energy production. Observing helium's signature taught that stars are predictable yet complex machines. Every photon carries evidence of the processes that power suns, connecting physics to the cosmos in tangible ways. Chapter 43. The discovery of cosmic rays revealed high-energy particles constantly bombarding Earth. Mostly from distant supernova, these invisible bullets travel near light speed. Cosmic rays taught us that space isn't empty. It's energetic and filled with motion. They influence atmospheric chemistry, climate, and even mutation rates. Observing them shows that the universe reaches Earth in subtle but measurable ways, constantly reminding us of our connection to the cosmos. Chapter 44. The observation of the first brown dwarfs filled a gap between stars and planets. Too small for sustained fusion, these failed stars glow faintly in infrared. Their discovery proved that nature produces a continuum of objects, not strict categories. Brown dwarfs challenge assumptions, showing that classification is fluid. Studying them helps us understand star formation, planetary physics, and the blurry line between worlds and stars. Chapter 45. The discovery of the first interstellar molecule, formaldehyde, showed that chemistry exists in space. Complex molecules float in clouds, eventually forming planets and potentially life's building blocks. This revelation connected astrochemistry to the origins of life, hinting that organic chemistry is universal. Even in near vacuum, atoms bond and dance. Space is a laboratory, vast and silent, quietly constructing the ingredients of life across the cosmos. Chapter 46. The first detection of cosmic neutrinos from beyond the solar system opened a new window to high-energy events. Traveling light years unimpeded, these particles carry unaltered information about distant explosions. Observing them allows scientists to study black holes, supernova, and cosmic collisions. Neutrinos act as cosmic messengers, invisible but revealing. Space communicates subtly. Chapter 47. The discovery of asteroid belts around other stars proved that debris disks are common. These belts are remnants of planetary formation, sometimes shaping worlds through collisions. Observing them helps understand system evolution and planet-building processes. Space recycles constantly, teaching that destruction and creation are intertwined. Even distant systems have patterns, echoes, and relics of their formative years, waiting for humans to detect and study. Chapter 49. The discovery of the first active galactic nucleus revealed that some galaxies harbor supermassive black holes consuming matter. These central engines emit jets, radiation, and enormous energy. Observing them taught that galaxies aren't static. They evolve, collide, and burn bright in their cores. Space is energetic, with processes far beyond human scale. The universe has engines, fires, and centers of power, shaping everything around them. Chapter 50. The mapping of dark matter in galaxy clusters revealed invisible scaffolding holding visible matter. Light bends around unseen mass, exposing the cosmos' hidden skeleton. Dark matter dominates gravitational behavior, shaping galaxy formation and evolution. Observing it shows that most of the universe is invisible yet vital. Space is largely hidden from direct view, and understanding it requires clever techniques, proving that reality is more mysterious than meets the eye. Chapter 51. The first detection of gravitational microlensing revealed hidden planets and dark objects. Light from distant stars bends around massive foreground objects, uncovering planets we couldn't see otherwise. This technique proved that the universe hides treasures in plain sight. Space isn't always obvious. Its secrets require clever observation. Microlensing shows that gravity itself can act as a lens, making invisible objects visible across cosmic distances. Chapter 53. The discovery of the first cosmic filament revealed the universe's web-like structure. Galaxies align along these massive threads, spanning millions of light years. Filaments connect clusters, shaping the distribution of matter. Observing them shows that the cosmos has organization at massive scales, even across emptiness. Space isn't random. It's structured, intricate, and interconnected. These invisible highways guide galaxies and tell the story of cosmic evolution. Chapter 54. The discovery of solar neutrino deficits led to understanding neutrino oscillations. Neutrinos change flavors as they travel, revealing new physics beyond the standard model. This solved a decades-old mystery. Fewer solar neutrinos reached Earth than expected. Observing these particles confirmed the sun's processes and expanded knowledge of fundamental particles. Even the tiniest cosmic messengers can reshape physics, proving that subtle phenomena carry profound truths. Chapter 55. The detection of rogue planets wandering between stars showed that planets don't always stay in orbit. These nomads drift through interstellar space, untethered, cold, and dark. Observing them revealed that planetary formation is chaotic and orbits can be lost. Space is unpredictable, even for objects we once assumed were stable. Rogue planets remind us that the universe has free spirits, silently roaming the void. Chapter 56. The discovery of the sun's corona heating problem puzzled scientists. The outer atmosphere is millions of degrees hotter than the surface. Solar magnetic waves and reconnection are responsible. Understanding this helps protect satellites, predict space weather, and explore stellar physics. Even the nearest star has mysteries. Observing the sun teaches that familiarity doesn't equal understanding. Our closest star still surprises us. Chapter 57. The discovery of interstellar dust revealed that light from stars dims and reddens along its path. Dust grains are tiny, but they shape visibility, chemistry, and planet formation. Observing these clouds explains why stars look different across distances. Even the emptiest space isn't empty. cosmic dust silently shapes what we see. Space is subtle, and even tiny particles tell stories on massive scales. Chapter 58. The first observation of the cosmic infrared background revealed the glow of ancient galaxies. Light from early stars, absorbed and re-emitted by dust, fills the universe in infrared. Observing it maps star formation over billions of years. Space has memory. It carries the light of its history. The infrared background shows that the cosmos is alive with echoes of creation, long after the stars first ignited. Chapter 59. The detection of stellar streams revealed the Milky Way's cannibalistic history. Tidally stripped stars from dwarf galaxies form streams orbiting our galaxy. These streams trace past mergers and galactic evolution. Observing them uncovers the dynamic, violent, and ongoing assembly of galaxies. Space preserves history in motion, showing that even the heavens record time, collisions, and growth on cosmic scales. Chapter 60. The discovery of magnetized jets from black holes revealed that gravity, spin, and magnetism create colossal beams. These jets extend thousands of light years, shaping surrounding galaxies. Observing them taught that black holes aren't just destructive. They influence structure, formation, and evolution. Space is interactive, energetic, and interconnected. Even invisible singularities leave visible imprints on the universe, proving that unseen forces can shape everything around them. Chapter 61. The discovery of supermassive black holes at the center of nearly every galaxy reshaped our understanding of galactic evolution. These giants influence star formation, galaxy shape, and cosmic dynamics. Observing them reveals that galaxies aren't isolated. They are ruled, shaped, and energized from their cores. Space isn't random. It's governed by unseen but immense forces, quietly orchestrating the dance of billions of stars. Chapter 62. The observation of interstellar clouds revealed regions where stars and planets are born. Gas and dust collapse under gravity, igniting fusion and forming suns. These clouds are cradles of creation, connecting life on Earth to cosmic cycles. Studying them shows that space recycles matter, endlessly crafting new worlds. The universe isn't static. It's a workshop of birth, growth, and transformation on unimaginable scales. Chapter 63. The detection of water on Mars reshaped ideas about habitability. Ancient riverbeds, ice caps, and hydrated minerals suggest the red planet once had flowing water. Observing this raised the possibility of past life and future human exploration. Space teaches that planets may carry clues to life's potential, even if hidden. Mars reminds humans that our neighboring worlds hold stories waiting to be uncovered. Chapter 64. The discovery of fast-spinning white dwarfs revealed stellar remnants with extreme rotation. Some complete hundreds of rotations per minute, radiating energy and emitting powerful signals. Observing them taught that even dead stars can exhibit extraordinary physics. Space hosts extremes, speed, density, and energy far beyond earthly experience. White dwarfs show that endings in the cosmos are never simple. They can surprise, endure, and dazzle. Chapter 65. The first detection of exoplanets using the transit method revolutionized planet hunting. Observing tiny dips in starlight reveals planets passing in front of their stars. This technique uncovered thousands of worlds, some Earth-sized, some bizarre. It showed that planets are common, diverse, and sometimes unlike anything in our solar system. Space hides treasures in subtle shadows, and careful observation unveils entire worlds. Chapter 66. The discovery of supernova 1987A offered the first close-up of a stellar explosion in modern times. Astronomers observed shockwaves, neutrinos, and evolving debris. Supernovae recycle elements essential for planets and life. Observing them in real time connected theory with reality. Space shows that endings create beginnings. The death of a star feeds the birth of new worlds, proving the universe thrives on cycles of creation. Chapter 67. The mapping of cosmic microwave background anisotropies revealed the seeds of galaxies. Tiny temperature differences in the early universe grew into massive structures over billions of years. Observing this background shows that the universe's large-scale patterns were determined at the very beginning. Space has memory, and the smallest variations can shape everything. The cosmos is not random. It follows rules that persist across time and space. Chapter 68. The discovery of Saturn's moons revealed a hidden solar system within a planet's orbit. Some moons harbor oceans beneath icy crusts, like Enceladus, hinting at potential. Chapter 69. The first detection of gravitational waves from neutron star collisions combined light and gravity signals. Observing these events confirmed kilinovae and element creation, including gold and platinum. Space is not silent. It speaks in waves and flashes. These collisions teach that the universe produces heavy elements through violent, beautiful processes. Humans witness creation of matter in real time, connecting cosmic catastrophes to the jewelry on Earth. Chapter 70. The discovery of the first triple star system with planets revealed unexpected stability in chaos. 3 suns orbiting each other with planets dancing among them defy intuition. Observing these systems shows that gravity allows intricate, long-lasting arrangements. Space creates balance, even in complexity. These exotic worlds prove that the cosmos experiments endlessly, combining motion, mass, and energy into patterns humans are only beginning to understand. Chapter 71. The discovery of ultra-compact dwarf galaxies revealed tiny but dense stellar systems. Despite their small size, they contain millions of stars packed tightly. Observing them showed that galaxies come in diverse forms, from giants to miniature marvels. Space isn't uniform. It experiments with scale and structure. Even the smallest galaxies tell stories about formation, evolution, and cosmic survival in ways that surprise astronomers. Chapter 72. The detection of intergalactic magnetic fields revealed invisible forces. Chapter 73. The discovery of rogue supermassive black holes roaming between galaxies shocked scientists. Ejected from collisions, these wanderers travel alone through intergalactic space. Observing them confirmed that cosmic interactions can produce extreme outcomes. Space isn't static or predictable. Massive forces can displace giants. Even the most powerful objects can be cast adrift, revealing that chaos and motion govern the universe on every scale. Chapter 74. The observation of the first exocomet showed that comets exist beyond our solar system. These icy travelers orbit distant stars, sometimes leaving tails visible across light years. Observing them proves that planetary systems everywhere experience activity, debris, and dynamics. Space recycles material, sends hints of formation, and creates natural spectacles. Even distant systems have fireworks, demonstrating that cosmic processes are universal, not unique to our neighborhood. Chapter 75. The discovery of tidally locked exoplanets revealed worlds with one side always facing their star. Extreme temperature differences create unique climates and potential habitability zones. Observing them challenged assumptions about planetary environments. Space experiments with conditions unimaginable on Earth. These worlds show that life and dynamics can emerge under strange rules, reminding humans that diversity is a cosmic constant. Chapter 76. The detection of the cosmic infrared background uncovered light from the first stars and galaxies. Observing it allows astronomers to map early star formation, even when dust hides them from optical view. Space carries a memory of creation, and photons travel billions of years to tell the story. The universe remembers its beginnings, showing that light is a storyteller, even across time and distance. Chapter 77. The discovery of the first ultra-hot Neptune revealed a planet with scorching temperatures, extreme winds, and unusual chemistry. Observing these worlds showed that planets aren't just variations of familiar types. They can defy expectations. Space creates extremes, testing physical laws in real conditions. These exotic planets teach that diversity in the cosmos is endless, and imagination often underestimates what nature produces. Chapter 78. The observation of the first kilonova confirmed that neutron star mergers create heavy elements. Gold, platinum, and rare metals originate from violent collisions. Space doesn't just exist. It manufactures matter through spectacular, destructive events. Observing kilonovae connects cosmic phenomena to tangible earthly materials. Even the most precious substances have violent, cosmic origins, linking humans to stellar processes in dramatic ways. Chapter 79. The discovery of ultra-diffuse galaxies challenged ideas about galactic density. These faint, spread-out galaxies contain very few stars, yet can be as large as the Milky Way. Observing them shows that space accommodates extremes: big, light, dark, and mysterious. Cosmic variety defies expectations. Even near-invisible galaxies reveal that the universe is full of subtle, surprising structures that continue to intrigue astronomers. Chapter 80. The detection of extremely metal-poor stars offered glimpses of the universe's earliest generations. These stars formed when heavy elements were scarce, preserving ancient chemical signatures. Observing them is like reading a cosmic fossil record. Space carries history in the form of matter, showing how elements evolved over time. These ancient stars remind humans that even small points of light hold stories billions of years old. Chapter 81. The discovery of ring galaxies revealed cosmic collisions in action. When one galaxy passes through another, it can create stunning rings of stars and gas. Observing them showed that galactic interactions are dramatic and artistic. Space isn't static. It sculpts matter into patterns visible across millions of light years. Ring galaxies are proof that cosmic violence can also produce breathtaking beauty. Chapter 82. The detection of super-Earths reshaped understanding of planet types. Larger than Earth, but smaller than Neptune, these worlds are common and diverse. Observing them revealed that planet formation produces a spectrum of possibilities. Space doesn't repeat patterns, it experiments endlessly. Super-Earths teach humans that our solar system is just one example among billions of variations across the galaxy. Chapter 83. The discovery of the most distant galaxy pushed the limits of observation. Light from this galaxy traveled over 13 billion years to reach Earth. Observing it is like looking back to the universe's infancy. Space preserves time, sending echoes of early formation. These distant galaxies show that humans can witness beginnings, revealing that even across unimaginable distances, the cosmos communicates its history. Chapter 84. The detection of icy exomoons suggested that moons beyond our solar system can host water and dynamic activity. Observing them opens possibilities for habitability outside planets. Space contains hidden niches where conditions may be right for life. Moons aren't just satellites. They can be active, interesting, and full of potential. Cosmic exploration reveals that life-friendly conditions might exist in unexpected places. Chapter 85. The observation of the most massive stars revealed objects over 100 times the Sun's mass. These giants burn fast, live short, and end violently as supernova or black holes. Observing them teaches how energy, gravity, and nuclear physics combine to shape cosmic evolution. Space hosts extremes humans can barely imagine. Massive stars remind us that the universe operates on scales of energy far beyond earthly experience. Chapter 86. The discovery of hot, fast-rotating stars revealed unexpected dynamics. These stars spin so quickly that their equators bulge, creating temperature and gravity variations. Observing them proved that stars aren't uniform. They have personality, rotation, and turbulence. Space experiments with physics in natural laboratories. Even distant suns display variation, reminding humans that nothing in the cosmos is truly simple. Chapter 87. The detection of rogue neutron stars traveling through space revealed stellar remnants wandering alone. Ejected from explosions or interactions, these stars move silently across the galaxy. Observing them showed that the universe is dynamic, and even dense remnants have independent trajectories. Space is full of lonely travelers, and their motion traces stories of past chaos, violence, and survival on cosmic scales. Chapter 88. The discovery of massive star clusters in nearby galaxies revealed concentrated stellar nurseries. Thousands of stars form in close proximity, interacting and influencing each other. Observing them shows that star formation is social, collaborative, and chaotic. Space is active, not isolated. Clusters teach humans that stellar evolution depends on environment, connections, and neighborhood effects, just like life on Earth. Chapter 89. The detection of the Sun's oscillations revealed its internal structure. Helioseismology uses vibrations to study temperature, density, and motion beneath the surface. Observing these waves confirmed models of fusion, rotation, and convection. Space teaches that even familiar objects have hidden layers. The Sun, our closest star, still carries secrets we uncover only by listening carefully to its subtle signals. Chapter 90. The observation of early galaxy mergers showed that the universe builds structure through collisions. Young galaxies combine, forming larger systems and triggering bursts of star formation. Space is dynamic, violent, and creative. Observing mergers proves that growth often comes from interaction, not isolation. Cosmic history is written in motion, collisions, and adaptation, revealing that the universe evolves through dramatic events. Chapter 91. The discovery of early supermassive black holes challenged formation theories. Some existed less than 1 billion years after the Big Bang, growing fast and influencing galaxies. Observing them revealed that the universe can produce enormous structures quickly. Space is efficient, powerful, and sometimes surprising. These early giants show that cosmic evolution isn't always slow. Extremes appear even in the universe's infancy. Chapter 92. The detection of water plumes on Europa sparked excitement for potential life. Subsurface oceans erupt through icy crusts, carrying hints of chemistry and energy. Observing these plumes showed that moons can harbor habitable environments, not just planets. Space contains hidden oceans and possibilities for life. Europa reminds humans that the most promising worlds might be icy and distant, challenging assumptions about where life can exist. Chapter 95. The discovery of massive galaxy clusters revealed cosmic giants bound by gravity. Thousands of galaxies orbit together, interacting and evolving collectively. Observing them shows how large-scale structures form and survive over billions of years. Space operates on both grand and intimate scales simultaneously. Galaxy clusters remind humans that mass and gravity shape reality, orchestrating complex, interconnected systems across the universe. Chapter 96. The detection of the first interstellar asteroid, Oumuamua, proved that objects travel between stars. Its unusual shape, spin, and trajectory puzzled scientists. Observing it showed that planetary systems exchange material and that space is not isolated. Even a single object can rewrite assumptions about formation, migration, and interstellar dynamics. Space is mobile, connected, and unpredictable. Chapter 97. The discovery of the coldest known brown dwarf revealed objects barely glowing in infrared. These failed stars straddle the line between planet and star. Observing them teaches that cosmic objects exist across continuous spectra, challenging classifications. Space experiments with temperature, mass, and composition. Even dim, faint objects carry information about formation, physics, and the hidden complexity of the universe. Chapter 98. The mapping of the cosmic web in unprecedented detail revealed filaments connecting galaxies and clusters. Observing these structures shows the universe's backbone, the scaffolding where matter gathers. Space is organized on unimaginable scales. The cosmic web proves that even across billions of light years, matter follows patterns, revealing order amidst apparent chaos. Humanity glimpses the architecture of the universe. Chapter 99. The discovery of planets orbiting binary stars challenged assumptions about stability. Worlds survive in complex gravitational environments, orbiting two suns. Observing them showed that planets adapt, survive, and persist in extreme conditions. Space experiments endlessly with possibilities. Binary planets remind humans that diversity in planetary systems exceeds imagination, and that life-supporting environments may exist in surprising configurations. Chapter 100. The detection of the most distant light in the universe captured photons from the first stars. Observing this light reveals the earliest cosmic structures and star formation. Space preserves history across billions of years, letting humans witness origins directly. Even the faintest signals carry stories of creation. The universe is a storyteller, and through observation, humanity can read the first chapters of everything we know about existence. These 100 discoveries show that the universe is bigger, stranger, and more beautiful than we ever imagined. Keep looking up, because every star, planet, and signal carries a story waiting to be uncovered.